Hello students. So in today's video, we are going to look at factorization. Now you have learned about factorization earlier. That is when we write a number as the product of its factors, the process is called factorization. And when we were doing factorization with numbers, we focus on getting them into their prime factorization, which means that the factors we want are prime numbers. So we have did that, right? However, in today's video, we're going to look at what happened when we start dealing with algebraic expression and we factorize algebraic expression, right? To be able to write algebraic expression in terms of its factors can be very useful later on, and especially when it comes to solving algebraic equations later. But here's the idea, right? So let me show you. We can factorize algebraic expression, all right? And we want to express it as a product of two or more of its factors. So it will look something like this. So informally, some students will say, okay, put them in brackets. But that's not exactly accurate. But of course, visually, that's what's happening. We have each of the factors encapsulate in a bracket, and these brackets portion, they multiply each other, and each one is actually a factor on itself, right? So there are a couple of techniques that we are going to learn. Let's start with the first one then, right? So the techniques that we're going to learn are extracting common factors. Informally, sometimes we say taking out common factors, but that's not a less accurate word. There's grouping of terms, very useful. There's something called the cross method that I'm going to introduce to you. Sometimes it's called cross method. There are other mathematicians and math teachers who may call it using the multiplication matrix, but they all follow the same concept and idea, so I can show it to you later. And finally, to make use of the algebraic identities, there are some of them that's very useful that we can use to speed up the process of factorization. So let's continue. So here's the first one, right? It's called factorization by extracting common factors. The idea behind it is to make use of the distributive law of algebra, right? So we know that we can expand algebraic expression by distributing the factors that is outside the bracket in. Okay, it works because of the idea behind the multiplication of the length of a rectangle. So if I have a length A here, I have the length B here, and a length C here. The area of this rectangle can be, if we use the idea of length times breadth, it will be B plus C, which is the length, multiplied by A. Alternatively, we can also find the area of each portion, which is AB and AC, and we add them together. So that's the principle behind it. And since this works, the reverse process also works. So as you can see, we can factorize if we have the form AB plus AC over here, right? Where's my highlighter? Yep, highlighter. Okay, the highlighter not working. There we go, right? We can actually just extract the common factor of these two terms, which is A, and present it outside the bracket in this manner. So I highlight in different color, you can see, right? So of course, if there's a subtraction, it doesn't matter because the principle behind doesn't change just because the sign changed from addition to subtraction. Okay. So some things to take note: when extracting a common factor, we will divide each term by the common factor, and the factorization is incomplete unless all common factors are extracted, right? So we have extracted the highest common factors among all the terms. So what does this mean? Okay, you will see some examples later, but here's some practice. So at this point, you can, if you have some idea how it works, to pause the video anytime so that you can try it first, and when you're satisfied with your attempt, you can continue the video and compare your answers with mine, right? But if you need more example, feel free to continue watching. Okay, so the first one over here is 10x plus 25. So when I observe 10x and 25, I will notice that the highest common factor between these two terms is actually 5. So if I will take out the common factor 5, what's left behind is actually 2, right? Because 10 to divide by 5 is 2, and then the x is still there, and then we have 5 over here. So when we look at the portion that's inside the brackets, you'll find that there is no more common factor. So this is the simplest form, and that's where we say that it has been factorized completely, right? Okay, next example. In this case, okay, we can see that 7 is a common factor. And then we will have CD minus 3D. Now, of course, these two terms have the letter D as common, but because we are trying to factorize all three terms, so the 14 here becomes a 2 here and it doesn't have a D. So that will be the simplest form. Okay. Continuing on the next example, this time round is a 3 that we can extract out. Okay. So what we have left, this will be 4x, right? And then 3 divided by 3 is 1. And that's the simplest form. Okay. Moving on to the next example, we have negative 21 ax plus 12. So in this case, there are two ways of doing this. We can extract out 3, right? If we extract out 3, what we have left will be negative 7. But wait, hold on. There's an A here and there's an A here. So I actually, other than extracting out numbers, we can actually extract out letters as well. So if we extract out the letter A, what I instead have is actually negative 7. The A has been extracted, so x over here. And then on this side, it will be just 4y. Okay. Now, alternatively, okay, if this negative in front here makes us uncomfortable, we can, of course, also extract out the negative 3a instead to obtain 7x minus 4y. This works, right? So it doesn't matter whether is it blue or the red portion, the solution on the screen. Both is acceptable if you are trying to factorize. But of course, based on the context and the purpose of why we are factorizing in the first place, there may be a preference. So this is more evident when we look at the examples in terms of factorization by grouping later. Okay. So here's the next example. Now over here, again, let's change the color back to blue. We have 4, but just like the previous example, the letters, they are common. So in this case, we have x squared that's common. So if I will extract x squared as well. So what remains will be y for the first term and 4 for the second term. There we are, right? Okay. Let's look at part F. Okay, part F, again, 2 can be extracted. But this time round, let's take a look at the letters carefully. We can extract out A, B, and C. So what is left is A minus 2B plus 5C. Okay, and finally, in this situation, something interesting happens. The bracketed portion, right, the x plus 3 bracketed portion, is actually the common factor. So we can actually take out the entire bracket, x plus 3, extract out the entire bracket as the common factor. And what I have left here instead will be 2 plus x, right, which will be this portion here and this portion here. Okay, that's what's left. Another example of seeing how this thing works. So we have this 1 minus x, 1 minus x. So what I get is extract out 1 minus x. Now here we need to be careful, right? A common error is to not realize that when we have a 1 minus x, there's actually a 1 in front here, right? It's actually 1 times the bracket. So just like when we just have the letter x, it's actually 1x. If we just have the letter y, it's 1y. So here, there's actually a 1, which means that over here, after extracting the bracket part, I actually have a 1 here left. And then you have 1 minus x. And of course, since 1 minus x and 1 minus x, they are repeated in this manner, we can actually write it in this form, 1 minus x squared. Okay, so with this, I hope you have a clearer understanding of how factorization by extracting common factor works. Okay, feel free to actually practice a couple more questions until you get the hang of it. And then let's move on to the next section. Perfect timing, right? Okay, so the next section we...
Hello, sir. I am almost fully charged. Please unplug me. Thank you.
Thank you, Siri. Well, I'm sorry for the interruption, Siri. I'd like to inform me that I'm currently charging my iPad and the battery is sufficient. All right. So let's continue. So extracting negative common factor. So earlier we extracted common factor, and there's one example over here, example D, where I show you that sometimes when we extract out the common factor, we can extract out the negative version of it, right? If that's the case, then we just divide accordingly. So this next section, we are going to keep that in mind, and this portion here is interesting, right? So where we have a situation where we have negative x and minus y or negative y, we can extract out negative 1, and that will result in this scenario. Okay, so this is the idea behind it, that we can always extract out negative 1 if we would like the sign to be reversed, right? Which is very, very useful. So let's take a look at these examples. So in the first example here, we have negative 3 x and negative 12. So since both of them are negative, I don't want all the negative to clutter up my bracket, right? So just to quick show, green color first. So this is what I don't want, right? If I will just take out 3, I will have negative x minus 4 over here. And I have the negative here and the negative here. It makes the bracket very cluttered, right? It's not ideal. So instead, I could extract out negative 3. And when I extract out negative 3, what remains is actually x plus 4. Take note that the negative get extracted out of the negative 12. Therefore, it becomes a positive 12, and then when you divide by 3, it gets 4. So be careful of the sign change over here. More examples. Okay, in this scenario, again, I'll prefer to extract out the negative version. Then we have 14 and 21, so the highest common factor will be 7. We have y that's common, so I'm left with 2x plus 3. But see, again, I see the negatives everywhere. It will be more convenient to extract out the negative version. So negative 4 will be good. So if I extract out negative 4, I'm left with 1 plus 4x plus 5xy. Right? And in this particular situation, now this is interesting. Okay, what happened is the bracket portion now looks different, right? You can see here is a plus 2b. And you can see on the other side, it is negative a minus 2b. So at first glance, it seems that the two brackets are two different things. However, okay, we note that actually, since there's negative here and the negative here, these negatives can actually be extracted out. So when I extract them out, I will get something like this. A plus 2b in the first bracket. And over here, instead of c, I extract out the negative 1, right? Extract out negative 1. So instead of plus c, I will have negative c or minus c. And in the bracket, now the sign actually flips and becomes a plus 2b. From here, you can see that the a plus 2b, these are the common. So this becomes a plus 2b. And then we have 2 minus c. Cool, right? Okay. More examples of this nature. Let's take a look, right? So here's another example. Okay, as you can see, at first glance, 2a minus b on this side and negative 2a plus b on this side, it seems that they are different. However, they are actually the same, except that the signs are flipped. So I can extract out negative 1 from the second one, and it will match, right? So if I have 2 here, okay, let me just adjust the screen a bit. 2a minus b. And if I strike out negative here, it becomes negative c. And this works out to be 2a minus b. So now, the bracket portion looks the same. Therefore, I continue to simplify. Factorize out the 2a minus b. I'm left with 2 minus c. Alright? And one more example to make sure that we really have a clear idea what's going on. Okay, so similarly, 2x minus y on this side, we have y minus 2x on this side. They are actually just opposite signs from each other. So I will take 2x minus y. On this term, okay, I will actually extract out negative. So positive 3 becomes negative 3. And then it becomes 2x minus y over here. Right? So put them together. 2x minus y is extracted. I'm left with 2 minus 3. And yes, interestingly, 2 minus 3 is just negative 1. So negative 1 is negative 1 times the bracket portion is, this is a scenario, right? So that's the simplest form that we can write this down. Okay. So is this factorized? Yes, it's factorized, right? Because we say factorized is a product, but what we have here is this is actually negative 1 multiply with 2x minus y. So it's still a factorized form. So this is all good, right? Okay. Right, let me just clean up my, okay. So this is all good. Okay. Right, moving on. The next section is factorization by grouping terms. So I will do this in the next video. I think it's a good place to press the pause button over here. Okay, and continue in the next video. Have a nice day.